So you're given a triple integral, and the question is to convert this into cylindrical and also into spherical. Let's see how that's done. First, what you want to do is figure out what this two-dimensional one is, and then over that region, think about what this would be. Okay? All right. First of all, this one here, because you have dy, that means this is y equal to this number and y equal to that. Okay. So you really have these two, y equal to 0 and y equals to negative square root of 25 minus x squared. That's easy, it's just the x-axis itself. This one, if you square both sides, it's y squared equal to 25 minus x squared. Add x squared to the other side, you get x squared plus y squared equal to 25, which is, what kind of shape is this?
Circle of radius.
It's a circle of radius 5. However, this one, it's not going to give you the entire circle, would it?
No.
Which one? It's only going to give you the bottom half because y can only take negative values. So it's going to be just the bottom half that you're talking about here. Okay. And then on this region, x is limited to 0 to negative 5 to 0. So you're only talking about negative 5 to 0. And in this interval, you start from this curve and you end that curve. You're going up, right? So you end up with this quarter circle. Okay? So we know that after all this calculation, that this first two describes the integral over this quarter circle of radius 5. Okay. Now, I use the language that it's surface to surface, curve to curve, point to point, right? Now, we have to think about what these surfaces are. Because I have dz, this must be z equal to 0. And z equal to that. Z equal to 0 is the xy plane. That's easy. Now let's think about what this is. Z equals to square root of 25 minus x squared minus y squared. If you square both sides, you get z squared equal to 25 minus x squared minus y squared. Add these to the other side, I get x squared plus y squared plus z squared equal to 25. What's that? It's a sphere of radius 5, right? Now, if you didn't know that, you can always take the xy trace, yz trace, and xz trace to find out that all of those give you a circle. And what kind of object would give you a circle in any cut? A sphere, right? Yeah. So for example, if you just wanted the xy trace, you set z equal to 0, and you get x squared plus y squared equal to 25. That's the circle of radius 5, isn't it? Yeah. The same way, if you want yz trace, you delete the x, and you get y squared plus z squared equal to 25. And that's a circle of radius 5 again. Okay? So it's a sphere of radius 5. And going back to this, you see that z can only be positive, which means this is really, it's a top half sphere. So here's what's happening. Any questions so far? Is that good? It's a top half sphere because z is only allowed to be positive. And in a sphere, if you only take the place where z is positive, it's only going to give you the half sphere. Okay? All right. So think about the following. You have xy plane, and over it you have a sphere of radius 5. Okay? And you're beginning here and you're ending at the sphere. What would you get? You're going to get this 1/8 of a sphere. That's what you're going to get, okay? Over this domain. Got it?
Yep.
Okay. Now the next thing to do is, in order to change this into first the cylindrical, you have to use these formulas. That see, cylindrical uses z and r and theta. Z is okay. There's nothing to be done for z, but any x and y has to be turned into r and theta. And in order to do that, you have to use x equal to r cosine theta and y equal to r sine theta. And in addition to this, it's good to have r squared equal to x squared plus y squared. Okay? So please remember these formulas. That's absolutely necessary in order to go from rectangular to cylindrical. And then once you have this, you immediately recognize that, hey, what's this? What should that be?
R squared.
R squared plus z squared, good. And then what about dz, dy, dx? dz is okay, but what do you do with dy, dx?
R.
R dr d theta, yes. You need this r, Don't forget about that r. That's, if you forget that, it's going to mess up everything. Okay. And then this is okay, but this here is not okay. I have x and y. What do you do? Isn't this 25 minus x squared plus y squared? Right? Same as this, right? And x squared plus y squared is r squared, so I can rewrite it as 25 minus r squared. All right?
Can you just make it 5 minus 12?
No, you can't. It's not the same as taking square root of each. Okay. All right. Okay, then once you've integrated this surface to surface, everything collapses down to the two-dimensional picture, which is this one. And our goal now is to use dr d theta to represent this portion of the plane. Okay? Now, let's first think about the r. If you are at the center shooting lasers, like that, okay? And then if you look at how those rays are overlapping the region that you're painting, starting from 0 and up till where?
5.
Up till 5, there's an overlap, right? So, and that's for all the direction once it has an overlap. So, in our case, it's easy. R goes from 0 to 5, as long as it has some overlap. But for what angles does it have the overlap with the given domain? Not here, not there, not there, not there, but here, right? Starting from here.
Yeah.
What's theta?
It's pi.
Pi through onto where?
3 pi over 2.
3 pi over 2. And beyond 3 pi over 2, you don't have any overlap, so we don't do those, okay? So the angle should be from pi to 3 pi over 2. Okay? So that's cylindrical, okay? You've represented this into cylindrical, and this integral will have the same value as this one if you computed both. All right, now let's go to spherical. For spherical, we retain the value of theta. That's always true as long as you don't choose funky values for your phi. As long as you don't choose phi to be beyond pi or less than negative, it's okay. Yes, your question?
Why isn't it not radical r squared plus z squared?
Oh, thank you. That's a mistake. Good.
And then
Good comment.
can we change the angle to 0 to pi over 2? Or can it, because I thought you said on the last one that the convention.
Oh, so you want this angle to be from 0 to pi over 2?
No, over here, 'cause didn't you say conventionally it's like from 0 to pi, that's it? Or is that the next one?
No, this I'm just copying this one.
Okay.
Yeah. It's see, this thing here in spherical, what is it? In spherical, what's the volume
Oh, it's
element?
phi.
Rho squared
Oh yeah, rho squared.
sine
Phi.
phi. Hopefully you remember this, okay? D rho, d theta, no, d phi, d theta. Okay. And all I did was I copied the value of theta over here because that's the only thing that doesn't change. You use the same theta for both cases, right? But rho and phi we have to figure out what to do, okay? All right. So first for rho, it's still a part of a sphere of radius 5, right? So if you, let's see if we can draw this thing. I should have drawn this. So if I draw, let me try my best. Let's see, if I say this is x and that's y, this is the case when x and y are both negative. So x is negative, y is negative. So you're talking about this region right here. This thing will correspond to this region. And over it you have this, over this region you have this half sphere, right? Yeah. But it's only the half sphere that's sliced this way. Maybe that's not the right place. Let's try. Let me try this again.
That looks about right.
Yeah, it's about right, but
It's just a
what
word.
if I look at it this way? I think that's better. If x is that way, and then, no, that's still not good. Oh, okay, I think this is better. If x is that, and y is that, and this is your z, then what you're having is, you have this quarter circle here, quarter circle there, and it's like this, and it's part of the sphere that's chopped. Okay, so if you took a ball and chopped in 8 pieces, and oh, this is actually like that. Okay, and maybe. Okay, so that's the sphere that we're talking about. Is that good? Right? And then, if you start to fill this up using d rho, which is from the origin, you did this, right? Rho would go from where to where? 0 up till 5. It will be extended until it hits the end of the sphere, and that length is 5 because that's the radius, right? So rho will go from 0 to 5. And then, how about phi? Phi is the angle from the North Pole, right? Definitely you have points where it's 0, phi is 0. And what's the maximum value of phi? Pi over 2. I mean, this is the point where it's farthest from the North Pole, right? And that angle is pi over 2, it's 90 degrees. So phi will go from 0 degrees up till 90 degrees, which is pi over 2. So phi goes from 0 to pi over 2. And then finally, this thing here has a nice formula for spherical coordinates. Rho is square root of x squared plus y squared plus z squared. Because, after all, what does this measure? That measures the distance from the origin. The distance from 0, 0, 0 to x, y, z is exactly this formula. And that's what we call rho, right? So, this thing here would be changed to rho. And that's it, okay? That's what you get if you change this into spherical coordinates.